Hello friends, in this video I am going to discuss one numerical which is related to concepts of reverted gear train. Reverted gear train is a train which generally used for the power transmission from driving shaft to driven shaft with the help of driving gear to driven gear, and the axis of the driving gear and the driven gear are coaxial. So let's start the numerical which is related to concepts of reverted gear train, and the numerical is: in a reverted gear train, speed ratio is 15, module pitch of gear A and gear B is 4 mm and gear C and gear D is 3 mm. Calculate the suitable number of teeth for gear. No gear is to have less than 25 teeth. So here we have a reverted gear train, and in this reverted gear train we are considering 4 gear: gear A, gear B, gear C and gear D. So it is represented by this diagram. Here we have one gear A which is in meshing condition with gear B, and gear B and gear C are mounted on a same shaft, and this gear C is in meshing condition with another gear, gear D. So let us consider this gear A is the driving gear and gear D is the driven gear. So the axis of both the gear should be coaxial, or these two gears should be coaxial. So here we have this particular diagram. So A is the driving gear which is rotating with particular speed in a particular direction, and it is in meshing condition with gear B. So whatever direction we are considering for gear A, opposite direction we will consider for gear B, and speed will also different, and it depends on the number of teeth over this gear B. Gear B and gear C we are considering as a compound gear which is mounted on a same shaft. So the speed of the gear B and gear C we can consider same because it depends on this particular speed of the shaft. And this gear C is in meshing condition with gear D. So this particular gear D we are considering driven gear. So the axis of the shaft of the driven gear will be coaxial to this driving gear. So this is representing a reverted gear train diagram. Here we have the condition for this reverted gear train. Speed ratio is given, it is 15. Module pitch for the gear A and gear B is given, it is 4 mm for both the gears because these two gears are in meshing condition. And gear C and gear D, module pitch is given, it is 3 mm. And for this particular gear, when this gear C and gear D is in meshing condition, module will considered as 3 mm. So all these values are given here. We have to calculate the suitable number of teeth for these 4 gears on the basis of value of module pitch between A and B and C and D and the speed ratio. One more condition we have to consider: no gear should have 25 or less than 25 teeth. So for this condition we have to determine the number of teeth for each and every gear for the reverted gear train. So let's start the solution. So the first value is given, speed ratio. So speed ratio we always consider between, or this particular speed ratio is representing for the reverted gear train. So this is the combined speed ratio we are considering. So it is represented by NA by ND, and this value is given 15. So these values are given for module pitch, and module pitch for gear A and gear B is same, it is 4, and module pitch for gear C and D is same, it is 3. So these values we have, and on the basis of these values we have to determine the number of teeth for each gear. And in this diagram we have one more value that is representing 200 mm. So 200 mm is representing the distance between the axis of the shaft, that is representing the center distance. So center distance or the distance between the axis of the shaft is represented by x, and this particular center distance we can determine with the help of radius of one gear and radius of another gear. So summation of radius of these two gears or the summation of radius of these two gear will represent the center distance. So here if we are considering RA, RB, RC and RD as the radius of each gear, so the center distance will be the summation of RA plus RB, RC plus RD. So as per that, center distance will be RA plus RB, so that is equals to 200 mm, and RC plus RD, that is 200 mm. So this value we have. Now these given values we have. Now let's start the solution to calculate the number of teeth for each and every gear. As we know, the formula of the center distance for each gears or for each gear train, it is represented by x equals to 1 by 2 dA plus dB. That is representing the diameter of both the gears, and it is given 200 mm. Now if we define this particular value of dA and dB in terms of, or we will solve this term dA and dB in terms of module and the number of teeth as per the concept of circular pitch. So the equation will be MA TA by 2 plus MB TB by 2. Here we have the term circular pitch as pi m, and module we always consider as D by T. So PC is representing pi into m. So if we want to define this value of D in terms of module, so module, it will be D equals to MT. And if we want to define the radius or D by 2, so this term will be MT by 2. So I'm writing this same term here in terms of this particular diameter of this gear A and gear B. So it will be MA TA by 2 plus MB TB by 2 as per this particular concept. So here we have the value of MA and MB, and the value of MA and MB is same. So we will put these values here. We will first simplify this term. So it will be MA TA plus TB by 2, that is equals to 200. So MA TA plus TB, that is equals to 400. Here I'm taking this MA and MB common because the value of MA and MB is same. Here we have MA, that is equals to MB equals to 4. So this equation will be 4 TA plus TB, that is equals to 400. So here from this equation we will get this first equation TA plus TB, that is equals to 400 by 4 or 100. So this equation is equation 1 I'm taking. So here we have this term on the basis of number of teeth for gear A and gear B. Now this equation is representing the first meshing condition when gear A is in meshing condition with gear B as per this diagram. Now gear B and gear C is mounted on the same shaft. So this gear C is in meshing condition with the driven gear, this gear D. So for this meshing condition, we will define the term of the center distance for this particular meshing condition when gear C and gear D are in meshing. So center distance for gear C and gear D is same, that is equal to center distance for the gear A and gear B. So condition we will define on the basis of module for gear C and gear D and number of teeth for gear C and gear D. So this equation will be x equals to 1 by 2 DC plus DD, where DC and DD are the diameter of gear C and gear D, and that DC by 2 or DD by 2 is representing the radius of gear C and gear D. So that is equal to, in terms of module, M equals to D by 2. So same term will be, it will be D equals to MT, or D by 2 will be MT by 2. So this equation will be for both the terms C and D, it will be MC TC by 2 plus MD TD by 2. Now here we have MC and MD is equivalent. So here we will take common this value, and X value we have 200. So this equation we have, now we will put the value of this MC. So we have this equation after calculation, TC plus TD equals to 133.3. After putting this value MC, we'll get this term TC plus TD, that is equals to 133.3. So here we have this particular equation as equation 2. So here we have two equation 1 and equation 2. Now on the basis of these two equations, we will define the number of teeth on each and every gear. Now as we know, the speed ratio, that is NA by ND, it is equals to 15. Speed ratio we always define on the basis of speed of driving gear and the driven gear. So this ratio will be NA by ND, that is equals to 15. This is the given value. Now if we simplify this term NA by ND, so this term will be NA by NB multiplied by NC by ND, that is equals to 15. So B and C are mounted on the same shaft. So the speed of gear B and speed of gear C we will consider same. But if we are considering this value same, so this will be cancelled out. So we will get this same term. Now here let us assume NA by NB, that is representing the speed ratio for the meshing condition of gear A with gear B. Speed ratio for the compound gear train or the speed ratio for the reverted gear train, or if we talk about epicyclic gear train, so here number of gears are involved. In that case, if we want to define the combined speed ratio, so we have to consider different meshing condition. Then we will define the speed ratio for different meshing condition, and after that we will multiply all those speed ratio to define the combined speed ratio for that particular gear train. So this NA by ND is representing the combined gear train speed ratio. And if we are simplifying this term, so here this particular term and this particular term is representing the separate speed ratio on the basis of meshing condition. So this NA by NB is representing the speed ratio for the first meshing condition when gear A is in meshing with the gear B. And here we don't have this value NA by NB. So let us assume this speed ratio NA by NB. For example, let us take this value as this NA by NB equivalent to 3. So here I am assuming this value, and after that, after getting the solution, we will check the value if it is value is feasible or not. So here I am assuming the speed ratio for the pair of gear A and B for meshing condition of gear A and B, it is 3. So in place of this NA by NB, we will put this value 3. So we will get the second speed ratio for the pair gear C and D. Let's assume this equation as equation 3. So from equation 3, we will get NC by ND. So NC by ND, we have 5. Now we have NA by NB and NC by ND, that is equals to 5. Now, as per the concept of speed ratio, we generally define the relation between the speed of each gear, that is equivalent to number of teeth. So here if we have NA by NB, so it will be equivalent to TB by TA. So from this equation, NA by NB, that is equals to TB by TA. TB and TA are representing the number of teeth on gear B and gear A. It is equivalent to 3. This is also representing the speed ratio. So on that basis, we can define the relation between the number of teeth of gear B and number of teeth of the gear A. So it will be TB equals to 3TA. So this condition we have. Similarly, for the second pair, C and D, here we have the speed ratio NC by ND, that is equals to 5. So it will be equivalent to the ratio of the number of teeth, so it will be TD by TC. So we can define the relation between D and C here. So TD, that is equals to 5 TC. And these values, if we are putting in these equation number 1 and equation number 2. So this equation we have as equation 1. So this value we will put TB equals to 3 TA. So TA we have 25. After solving this term, TA plus 3TA, in place of TB we will put 3TA. So it will be 4TA equals to 100. So the number of teeth on gear A will be 25. So we have the value of TA. Now we can find out the value of TB from this equation. So 3 into TA will be TB. So here we have TB equals to 3 into 25. So it will be 75. So this TB is representing the number of teeth on gear B. Now we have this value of TA and TB. So this is representing the number of teeth of two meshing gear or two pair, TA or gear A and gear B. Now let's consider the second condition. In second condition, it is given TD equals to 5 TC. So we will use equation number 2. So this equation is the equation number 2, TD plus TC equals to 133.3, and we will put TD equals to 5 TC. So this equation will be 6 TC, that is equals to 133.3. So the value of TC we are getting here, that is 22.21. So in place of 22.21, we can write down 23. But one condition is given here, that the number of teeth should not be less than 25. So this TC, we should have 25. So the TC value in place of 22.21, this is representing the value in decimal. So we will consider a whole value for number of teeth, and on the basis of this whole value, we will define the diameter or pitch circle diameter of each gear when we design the gear. So this TC, if the condition is given, if the condition is not given, in that case we can use 23, but condition is given that number of teeth should not be less than 25, so this TC will be 25 only, and this is representing the number of teeth on the gear C. Now similarly, we can define the number of teeth on gear D. We have the value of TC, so we will put this particular value here, 5 into TC. So number of teeth on gear D, it will be 5 into TC, so it will be 125. So now we have all the number of teeth for each gear. So here we have all number of teeth. So here we have the solution of this numerical TA, TB, TC and TD. TA is 25, TB is 75, TC is 25 and TD is 125. Now we have assumed one thing here, that the speed ratio of pair of gear A and B, it is 3. Now this is the assumed value. Now if we want to check that this particular value is right or not, or this particular value is feasible or not for this particular condition, or for these number of teeth of each and every gear, so here we will check this value on the basis of concept of speed ratio for reverted gear train. So this equation is representing the speed ratio for the reverted gear train. It is representing NA by ND, that is equals to two meshing condition we have. So on the basis of two meshing condition, this equation will be TB by TA into TD by TC. All these values we have number of teeth for each gear. So we will put all these values and we will check either this ratio is right or not. So as per the calculation, we already have the value of TB, TD, TA and TC, and these value we are getting because of the assumption. So this assumption NA by NB, it is equals to 3. It is representing these values, and if this equation NA by ND after putting these value TB, TD, TA and TC is giving the same speed ratio which we already have, which is given, so it means that assumption is feasible for this particular condition. So here after calculation we are getting this value NA by ND, that is equals to 15. So that assumption NA by NB is right for this particular calculation. It means we have the right number of teeth for each and every gear. So this is the solution of the reverted gear train. Thank you so much.